Hello and welcome everyone. Welcome back to the channel. I am your host Stefan Burns, geologist, geophysicist, your cosmic bro, here to help you understand what's happening. And well, in 3 days, there is a moon mission planned by NASA. The first manned moon mission in more than 50 years, going back to 1972. And well, it's not really the best time to do it in my opinion. They had to scrub the prior launch window for early February. There was a ton of solar activity back then. It was really quite historic. They scrubbed it because of what they called different like gas leaks. I think it was like a liquid hydrogen or helium leak, something with the rocket. And there are known issues with the heat shield for the Orion spacecraft. Those were identified with the Artemis I mission in 2022, which was an unmanned mission, but with a lot of the same, you could say, spacecraft and gear, equipment, etc. Well, they may cancel again, but at this moment in time, it looks like they are going to proceed for a launch on April 1st. April Fool's Day, which is also the full moon. And so all that combined together is quite concerning in my mind. I think it's awesome that we're pursuing space again in a real way, but it is concerning in my mind because there is a much higher risk than normal during this time frame because of the solar activity that we have. We have tons of sunspots on the Earth-facing side of the sun. We've had 3 coronal mass ejections launch in a row from one specific sunspot, which will be perfectly aligned with the Earth. So it'll be a sun, moon, or sorry, it'll be sun, Earth, moon alignment, but it's going to be perfectly aligned with us on the day of the launch. And then if that does decide to erupt like this with a big coronal mass ejection or even like a particle storm, well, if they do launch, those astronauts in space will get hit by that radiation. And well, I reviewed their safety protocols. There's not that much shielding on this thing, right? Lead shielding, it's very heavy, so you don't really launch out into space. Instead, they're going to be stacking like containers of water and pajamas and food on top of them if a big solar storm hits. You'll even see that in this video here. So this is pretty crazy. So we're going to do a complete breakdown in this video. I'll discuss a bit about the Artemis II mission, of course, get you up to speed. Weather right now is looking like an 80% A-OK for the launch. So there is, some chance that the weather delays it. Of course, if they find some other things in their pre-checks, that could delay it further. I think it should be delayed because of the space weather, because, well, there's a real risk to this. And it's not one that they've addressed. Back in February with the first proposed time window for Artemis II before they scrubbed it because of the leak, we had these incredibly active sunspots doing X flares, I mean near Carrington level flares, like they had the potential to. And they didn't once reference the sunspots or solar activity. Kind of blows my mind. So, yeah, a lot happier right now. Hope you are all doing well. Hello and welcome. We will do a question and answer also afterwards. So if you have any questions, then you can go ahead and ask those in the chat during the Q&A. If you want to make sure your question gets answered, then attach that to a super thanks. I see those all because they get put into a separate list. So I can definitely, guarantee that I'll answer those questions. And yeah, with that, I hope you're all doing well. Happy Sunday, Sun Day. It is the 29th of March, and they will be doing this mission launching from Florida as they normally do. So with that, let's get into it. Let's look at our sun right now. Here's a whole bunch of animations and visualizations of the sun. What's the sun actually look like right now? Well, here is the sun right now. So we see lots of sunspots on the sun, more rotating in every moment. This is a 48-hour view. At the very end will be the present moment. So we see that coming in right about here. There it is. So we see at the, and let me actually just take this and take it all the way to the end really quick so you can see. This is what we have right now. In 3 days' time, there are going to be sunspots across the entire Earth-facing side of the sun. So we see this big stretch here, northern hemisphere. This is the most active sunspot right now in the southern hemisphere. So that one is not yet Earth center direct. Here it is again where it is right now. In 3 days' time, April 1st, April 2nd, April 3rd, it's going to be right here in what we call the strike zone. This guy has launched a lot out over the past few days. So very active sun at this moment in time. Very active in terms of sunspots. We're about 140, 150 sunspots right now for the daily count, which is elevated quite a bit above, let's say, 0 solar minimum. Ideally, we'd be doing these space missions during solar minimum, when there's no risk of a solar flare and a giant coronal mass ejection. But instead, they're targeting it for basically solar maximum, the very end of solar maximum, beginning of the descending phase. We're at that border right now. So this guy has been very, very active. That's 4405. I can show you that with our chronograph view here. This goes back to the 25th. You'll see this first coronal mass ejection launched from that sunspot group. We'll see a second one launch out afterwards. Well, there's another one. There's the second one. So there's actually been 4, right? And then we'll see this big one follow up behind just recently. There's the big coronal mass ejection that just launched off in the past 24 to 36 hours. If that had been Earth direct, that would be a pretty big impact. We're talking probably at least a G3 geomagnetic storm, a lot of solar particle flux coming in. You know, the magnetic field is oscillating, vibrating, and the plasmasphere is supercharged and swirling around. That's what you don't want when you have astronauts in space, especially when they are aboard a spacecraft that doesn't really have any shielding. We'll talk about it a bit more, but they really don't have shielding specific for this. So that's the problem. Here we can look at the orbit of Artemis II, okay? So here we have the orbit of Artemis II. They are going to launch supposedly on the 1st. It may get pushed back. It's a very real possibility, okay? So maybe it gets pushed back 2 months and then they actually launch when there's no sunspots on the Earth-facing side. They could do that. There is a zone right now on the sun that's pretty low in sunspots. Just wait for that guy to rotate around, then do the mission. That's what would make sense. But, you know, this stuff is political now too. So with with everything that's happening, they also want to, you know, the United States government wants to wave a win around. And this would be a win if it goes successful. And it's probably the most likely outcome. If it does launch, that everything will go fine. That doesn't mean that the risk is 0 though. So here we see the orbit going out. It will go to the moon. We're not landing on the moon. It will do a little slingshot around the moon, and then it will fall back into Earth. So what's interesting about the Artemis II mission is that in fact, it'll be the deepest mission to space ever. So with Apollo, they of course went to the moon. They landed on the moon. That's more significant overall. But they did not extend out as far beyond the orbit of the moon as Artemis II is. So this will be the deepest mission into space ever, should the mission actually occur. It's looking like that will occur. And it's about a 10-day mission. We see the days since launch right there. So we're looking at a 10-day window where if you have any sort of solar activity, it could be pretty dramatic. And it generally takes about 2 to 3 days for a coronal mass ejection to reach the Earth. We can look at a coronal mass ejection right here. We see this propaganda. This is a visualization, by the way, okay? But we just get a sense of, you know, how these plasma flux tubes propagate out through space. It takes about 2-3 days. The fastest transit ever recorded is like 14 hours. But that's a very special type of solar flare and coronal mass ejection. Very, very rare, very unlikely. I mean, it's always possible if you have the right sunspotting conditions, but usually 2-3 days. So if something was to launch, let's say in the next 2 days, we could have the Artemis mission basically blasting off as this storm is coming in. There's a whole range of possibilities here, but being in space for 10 days means that there's a long time window for there to be, let's say, even a big solar flare and coronal mass ejection right here. that then impacts 3 days later as they're then coming back around. So this is pretty big stuff. Now we can look at our astronauts here. We wish them the best, of course. Here's the Space Launch System, the biggest rocket ever devised by NASA. We see, I think there's only 4 astronauts, so I think there may be 2 other people here hanging out, or maybe they're the backup astronauts. You know, they always have a couple people on standby in case someone, you know, calls in sick. So that is the Space Launch System right there. Let us look at this visualization similar to the one we just looked at in terms of the orbit, but now incorporating Earth's magnetic field, because this is really the key here. It's the particle flux, not only from the sun, but also from the Earth, that poses a risk for astronauts in space. And this is always going to be a risk for astronauts in space. It's going to be a risk for anyone that settles on the moon with a moon base. There's no magnetic field for the moon. So we're going to have to devise ways to protect from these high energy particles. And contrary to what some people think, right, it's like Earth's magnetic field is protecting us from these particles in space weather. That's true. It's not the only thing, though, protecting us. On the surface, we have multiple layers protecting us. Earth's magnetic field is the first step, routing a lot of these high energy particles around. But Earth's magnetic field itself contains a lot of high energy particles. So when you're in the radiation belts in the plasmasphere, you're also being exposed to a very high load of relativistic flux. These are particles traveling near the speed of light. Their kinetic energy is insane. Here we see some of that solar particle flux. Here, because it's outside of the magnetosphere, it's not being preferentially routed around at all. So here you're getting just a ton of solar flux. If a coronal mass ejection is to hit Artemis II and hit Earth in general during this time frame, we could see a surge in particle flux like that. Then it will come back in and also be exposed to particle flux. The reason why we aren't exposed to particle flux at the surface is not only do we have the magnetic field routing solar and cosmic particles away, we also have the atmosphere absorbing these particles that come in from space. So even though you're still in the magnetic field, let's say if you're orbiting around like right here, this first slingshot attempt, you're still in the radiation belts. You're still in a very high particle flux environment, and then that only basically increases if you go into a space environment being hit by a big radiation storm from the sun. So that is the big thing. Now this launch date, April 1st, is coinciding with the full moon. So in this animation, they show the moon already at like a quarter position, basically. The magnetotail stretches away from the sun. So during a full moon, the moon is perfectly in this magnetotail, all right? This animation, though, was made for the first launch back in February. The moon phase was different. So it's going to take, I think it's about 3 days to reach the moon. So in that time frame, the moon will have moved to the edge of the magnetotail if they launch on the first, the full moon, and then they'll circle around the moon, and then they'll come back in, as we see here, at roughly that same angle. So they will be at the border of the magnetic field and the magnetotail during the entire mission if they launch on the 1st of April. And we recently had some space weather that loaded the magnetotail with more plasma than normal, which is interesting. When you have a northward solar wind magnetic field, it injects a lot of energy specifically into the magnetotail versus deeper into the radiation belts and into the ionosphere directly. So that just happened. These effects take some time. So they are right now, the magnetotail right now is supercharged compared to normal. And here's our capsule. Here's the Orion capsule. We see quite a few components to it. Here's what it looks like not disassembled. Here we see the top of the capsule, the launch abort system, and some other stuff. Here's the crew module, the service module. And what will happen is this will completely launch out. And then if they come back, right, the whole deal, this will then basically disconnect, and this will fly down into the atmosphere. and splashed down in the ocean. There's a heat shield on this. There was a lot of heat shield tiles that were lost back with Artemis 1 in 2022. And it has been given the all clear now. They have been doing some follow-up testing more, but there's still a lot of people concerned about that heat shield because there were like tiles ripping off of it during re-entry. So that's another risk with this space mission, is that you have the heat shield itself on the way down, just maybe a catastrophic failure. We hope not. The other thing with the particle flux too is that it can affect electronics. So it's not just about people being hit by high energy particles and basically receiving like, 10,000 chest x-rays at once, or the equivalent of like, nuclear bomb radiation hitting them or something like that. This is what that is. It's all the same. It's also about sensitive electronics being hit by more high energy particles, and that can cause then a hardware and or software failure, because you get a particle hitting a transistor gate in a circuit and all of a sudden it causes it to flip to a 0 instead of a 1 where it's supposed to be. Then you can have a critical software failure because now the code's not executing. So these are real issues too that they talk about, but maybe not as much as they should. Here we can see that they are getting ready for Artemis II. So this is spaceflight now. A bunch of photographers are already setting up in anticipation of the launch. So we can just kind of see here how far away they are, and we can see that the Space Launch System is on the platform. This was just released a few hours ago, as we see here. So they are ready to rock and roll. Again, it's about an 80% chance right now that they'll be given the go-ahead based off of the weather. We can look at that report right here. Launch mission execution forecast. Primary concerns, 20%. Cumulus clouds, thick cloud layers, ground winds. Overall, things are looking like a go for April Fools for this launch. Interesting choice of days. Honestly, you think they would just push back one day? Like, considering their reputation, so many people have poor reputations of NASA. Considering their reputation, why not push it back to April 2nd? Why give them fodder, right, for conspiracies or more? Here we see our radiation belts. They're pretty charged up right now. We've had some big solar impacts that have charged them up. So here is March 24th, 25th. We'll see them slowly lose charge going up to today. There has been some solar wind which has pulled a little bit of energy out of the radiation belts, but should that come to a close, that's going to then recharge them up even more. So right now, in general, they're pretty well charged up. We see the 29th right there, and so you see where they are. It's a little bit above normal levels right now. It's a little bit above normal levels at this moment in time. And one other wild card factor is that, and let me show you actually, I have to show you the sunspots on the sun. I showed you the activity and we did look at them, but we can look at them very directly right here. So let's look at these sunspots. This is for the past 48 hours, all right? So we see sunspots here. This is 4405. Sorry, that's not 4405. 4405 is rotating in, very active. We'll see that come in. Actually, this is going back like 5 days. This is going back to the 24th. Let me rewind this because I wanted to show you how they're rotating into view. And we've been forecasting these sunspots to arrive for some time because we had some view of them on the far side back earlier around mid-March. So we see them rotating in. You'll see growth of this sunspot group there. This flux lobe splits apart. That one then migrates over here. We see this is 4401, 2, 3, 5, 6. This is 4399 right there. This guy's getting pretty big. So now you can see that we are fully ready to rock and roll with sunspots on the Earth-facing side. So you think that they would choose a time where there simply wasn't that many sunspots. Here's the other wild card factor, is that we have, at this moment in time, a sungrazer comet flying in to perform its perihelion on April 4th. So this comet C2026 A1 maps is a sungrazer, meaning it gets very, very close to the sun. Its separation distance from the sun will be less than the Earth-Moon separation distance. Its perihelion being just 0.005 astronomical units. And we've seen many times now that when you get a comet to get close to the sun, we often see more solar activity, more solar flares, coronal mass ejections. So, yeah, April 4th is going to be 3 days after April 1st, which is just at the beginning, effectively, of the Artemis II space mission, which is slated to last 10 days if they do launch on the 1st. So they'll be launching, if they hold to that time window, right as a sungrazer comet is coming in. And it's not going to be coming in at 1 astronomical unit as closest, or 0.5, but we're talking 0.005. It could even impact the sun. And we have seen how comet impacts have triggered very large coronal mass ejections. I've shown this video. This is from 2011. I'll show you guys again for anyone that's new here. If you are, hello and welcome. I'm your host, Stefan Burns. We cover what's happening with space, the Earth, the cosmos, and more. We'll get this size properly here. We'll see this comet impact the sun here. This is back in September and October of 2011. We see this comet coming in there. Basically, it becomes plasma, blasts off this big coronal mass ejection, the sun. Most space people say it's just a complete coincidence, but the timing literally is perfect. And I've discussed the physics of this many times. To keep it really short and sweet, basically this comet gets ripped to shreds by the high gravity of the sun. That's also accelerating it very, very quickly. You have something known as the critical velocity. If your kinetic velocity gets high enough, any material can actually simply just ionize into plasma because it's so energized, because its kinetic velocity is so high. So the gravity pulls it in, ionizes it into plasma, and now it's not simply a piece of rock hitting the sun. You think, how does that do anything? Now you have a stream of plasma coming in, disrupting the electromagnetic systems of the sun. And you don't need that much relativistic flux flowing through a circuit to all of a sudden destabilize it and cause a latent release of energy, because you have a whole bunch of plasma stored in a delicate flux tube, and then you get this high energy particle flux come in from the external environment, then boom shakalaka. So that's how that effectively works, to keep it simple. You'll notice this comet in 2011 coming in at an angle like this, and then that coronal mass ejection blasting off like that, okay? So we all see it 2D, but that's the orientation. So it's not that it hit one side and somehow on the other side, it's really following exactly where it hit. So yeah, I mean, we have a lot of examples of comets influencing solar activity, and this is the most direct showing a comet directly impacting the sun, causing a big coronal mass ejection. And that is a possibility for sure with comet C2026 A1 maps. I don't think it's the highest likelihood. I do think it'll perform its perihelion. It may not survive its perihelion. There is quite a bit of evidence that it just simply may not survive, may not be big enough to do that. But here we see it right now. If I hit play, we'll see its perihelion on the 4th of April. There it is, really quick. As you can see, it may not fly out again if it doesn't survive. But if they launch on the 1st of April, it'll be right when this comet is doing its perihelion, just a few days later, and that could provoke the sun. It could provoke the sun when we already have huge amounts of sunspots on the sun, as you can see here. And this one in particular, you'll see 4405 rotating in to be Earth center direct right around the 1st of April, 1st, 2nd, 3rd of April. It has been the most active of all of them, having released 3 coronal mass ejections, and the last one being quite large. So there's 4405 right there, but about 150 sunspots on the sun right now. And this will be completely covered exactly right when Artemis II launches, should they choose to launch. Yeah, so that's quite a lot to cover, to kind of crunch in the head Here, let's look at some information. I asked Google Gemini some questions on this, and being someone that knows this, I can verify that this is good info that it spit back. You always have to kind of verify it. But a technical report, Orion spacecraft radiation shielding, Artemis II. The Artemis II mission represents the first crewed deep space mission in 50 years, exposing astronauts to a high energy particle environment, specifically significantly harsher than low Earth orbit. Or, for example, here on the surface, we're really protected by the atmosphere. Magnetic field, then the ionosphere, then the atmosphere. Unlike science fiction concepts of specialized lead or magnetic force fields, the Orion spacecraft's radiation protection strategy primarily relies on mass shielding, repurposing existing onboard stowage and highly advanced active dosimetry and warning systems. That's not going to protect you. It's just going to let you know when there's something happening. The deep space radiation environment. So you have radiation trapped in the radiation belts, also known as the Van Allen belts. Two giant donut-sized regions of high-energy particles trapped by Earth's magnetic field. Orion will cross these belts multiple times due to its high Earth orbit checkout phase. So that first slingshot, when it comes back in, all that stuff. Galactic cosmic rays, which can be extremely high energy. The highest energy particles are going to be cosmic in origin from supernovas and all these other things. Okay, highly energetic particles originating from outside our solar system, then solar particle events. These are sudden intense bursts of energetic particles from the sun, mostly protons, coronal mass ejections. If you get one of those, it can really be a huge increase, like orders of magnitude increase in particle flux, the radiation dose, and more. They're already going to be at radiation levels like 50 to 100 times that of Earth. So this could be really a big deal. The shielding methodology. Radiation shielding in space is fundamentally about mass, at least for the Orion probe. Charged particles are slowed and absorbed as they pass through dense matter. So they have, as their foundational layer protection, the actual structure of their space probe. The crew's module pressure vessel is constructed from 7 large friction stir welded aluminum alloy panels. Aluminum's not that good of a shield, by the way, but it's metal, so it's better than, you know, linen or cotton blowing in the breeze. Thermal protection system. This is the heat shield. You have 1,300 silica fiber tiles and the 16.5 foot Avcoat ablative heat shield, providing more ambient mass. It's not really designed for absorbing high energy particles or shielding like lead would be, but it's going to absorb some just through its mass. And then the event of an emergency solar storm, the crew relies on active reconfiguration protocol rather than a dedicated bunker. They'll reposition themselves in the central backbone assembly of the module, which is the floor area. They'll construct a temporary shelter using dense onboard materials like stowage bags, water dispensers, and other equipment around themselves to maximize the mass between their bodies and incoming particles. But that's probably going to help like by 1% or something. Basically, they are not going to have good shielding up there. And it's really a question of what the decision calculus was is, okay, well, if something happens, what will the highest radiation dose be? Like, is it equivalent to a month on the International Space Station? Is it equivalent to 10,000 hours flown on a commercial airliner? Like, is it going to be within acceptable limits? And if so, then we can take that risk. And the astronauts signed the papers because they want to go to space. So they have a variety of active monitoring and warning systems, dosimeters, and of course all our equipment down on the surface and our space weather instruments. So they will get heads up on this, and so they can take those precautions. But really, there's nothing that you can really do to protect from like a very high energy event. It's just how the spacecraft is built. Simply is like light shielding in a high energy particle flux environment. If we look here, I asked what the energy range of relativistic particles in Earth's radiation belts and magnetotail are, because again, this is now happening during the full moon, means that they'll be kind of in that magnetotail zone as they launch out towards the moon, which will be moving out of the magnetotail about 3 days after the full moon. So you have the radiation belts, and you can get electrons that have values of 0.5 mega electron volts to 15 mega electron volts in the outer and inner belts, but really the outer belt where you have these electrons. The inner belt is mostly comprised of protons. Their energies can be much higher, 10 mega electron volts to a greater than 1 giga electron volt. So you have an electron volt, 1,000 times stronger than that, a kilo electron volt, 1,000 times stronger than that, a mega electron volt, 1,000 times stronger than that, a giga electron volt. So that's how it scales. So these can be very, very strong particles already within Earth's magnetic field. Not necessarily just because you're in Earth's magnetic field for more of the mission does not mean that you're safe from particle flux. It's really us on the surface being protected by Earth's magnetic field and the ionosphere and the stratosphere, and also like the ionosphere, the mesosphere, the stratosphere, and the troposphere, effectively. Now, Earth's magnetotail also contains some very high energy particles. Often they are stronger than those in the radiation belts. We have relativistic electrons. These can be 100 keV to 2 mega electron volts. And then energetic protons, they can be accelerated up to about 1 mega electron volt during a strong reconnection event. So you have energy there as well. The density of these particles is quite low, but the energy is quite high. And Artemis mission, they will be flying into this. So I wanted to give you this update. Of course, I wish them all the best. I just personally don't think it's the best idea to send our astronauts to space when there are this many sunspots on the Earth-facing side of the sun. And we're, seeing activity from this one right there, 3 coronal mass ejections back to back to back. The last one being quite large. We can see that. If we go here in the video, we'll see this third one launch off. So a big coronal mass ejection just in the past 48 hours from 4405. And yeah, you have other issues. People aren't confident in the Space Launch System. They're not confident in the heat shields. It just feels like, and things have already been delayed so much, but at the same time, it feels like a rush job just to get a win. That's kind of my opinion on it. So yeah, we'll do a quick question and answer. I don't see any questions in the super chat thread yet. So if you want to make sure your question gets answered, add it to a super chat. Otherwise, I'll take some from the regular chat to start. So thank you, and hope you're all doing well today on this sun day. I can show you really quick the X-ray flux. It's not like it was back in February. It was a lot worse in February. Here we see our X-ray flux. We have been kind of ramping up, but recently settled off. That's what triggered that bigger coronal mass ejection right there. So thankfully things haven't been doing, like we haven't been having big activity, but with all the sunspots, the potential is certainly heightened. There are worse periods of time than right now to launch Artemis II. Certainly, from different periods during solar maximum, this solar maximum, there are definitely periods of time that would have been much worse, but it's also not maybe the ideal time. And when it comes to things like this, I think we should really aim to get everything as close to perfect as possible. Well, why take an unnecessary risk for humans, for the spacecraft, the electronics, everything like that. That's kind of my thought process there. And Murphlaws is asking, do you really believe they are going somewhere? Well, yeah, we have people already setting up cameras at the, the launch site in Florida. So people go and they see those launches all the time. This is going to be the first one in 50 years. But now more than ever, people are going to have cameras zoomed in, astronauts walking across the bridge and all of that. So if we see it and there's hundreds of independent people and organizations reporting on it, then yeah, I'm going to believe it. But it's not going to happen until it actually happens. And a question from one of mine, space drag effect on communication during flight. Probably not much. I mean, space drag in and of itself isn't going to affect communication as far as I know. It's going to be more so if there's some big particle storm or something that could affect communication. But then I'd be more worried about the radiation risk rather than maybe comms. You're more likely to have comm issues. For example, when they're on the far side of the moon, just temporarily, we'll lose communication with them. If we're along the ecliptic plane, now if we're slightly above and we can get that signal through, then we won't. So I don't know the answer to that. And she called me trash, is asking, what up? Just got here. Any more falling rocks to watch out for? Yeah, we've had some fireballs over Trinidad and Tobago, and also I've been getting a lot of reports from all of you, both on the YouTube and also on X, of different fireballs that you've seen that don't necessarily have reports. So there is a classification thing that we have to be mindful of in terms of if you just see a shooting star, that's not a fireball. Fireball is definitely a different thing. But I mean, we're undoubtedly in a surge right now of fireball and large meteor sightings. So I think that a lot of these reports that people are giving me are accurate, and they're being verified by oftentimes by video from different people. So yeah, we're still in the thick of that. I'll keep you up to date on that, of course, if you stay up to date with my channel. And Callie J is asking, with the comet coming in, is it safe to do launch or no difference? I mean, I think the most likely outcome is that things will be fine. Even with the comet, even with the sunspots, I think that the most likely outcome is that things will be fine. But I don't think it's going to help, A. And B, I do think it raises the risk quite significantly. Now, I'm this uneducated layperson on this topic. I've never worked with NASA. I don't work for any sort of space agency. I'm just someone that's been researching into this like crazy and reporting for you on it basically daily now for a few years. So I'm also not clueless, okay? So I think, again, the highest likelihood is that everything's fine. That's what we're hoping for. But if it's to occur. But I think that risk factor did go up significantly as a result of these factors that we have converging together. The full moon's already an energetic like moment in time. Tons of sunspots on the Earth-facing side of the sun. A sungrazer comet coming in. Like, I don't think it's that far behind this most likely safe outcome scenario. That's the thing. I think it's a bit more of a toss-up than maybe the people at NASA would like to admit. But because they need that political win or whatever, I don't know. Because they need it, like, they're like, just go ahead, do it. I'm not behind those doors. I don't know what they're saying, talking about, discussing, you know. And a key thing is they're not landing on the moon with this mission. It's just an orbit around the moon. Artemis II will be a moon mission, and now new announcements have come out from NASA. Originally, they were going to build like a space station around the moon. Now they're going to build a moon base. So they say. So not landing on the moon, but the deepest into space that we've ever gone before should this mission go ahead. And eventually it will go ahead. Just the question is kind of when. And do astronauts have the right to call the flight, stop it for whatever reason they deem necessary? I don't know. I don't know. I mean, I think probably every astronaut reserves a right to just put their hand up before they walk on and be like, I'm out. But, you know, they don't want to do that. It'd be, you don't sign up for this to then do that unless, like, maybe you're in the middle of a heart attack or something, right? What if NASA has some alien technology that will shield Artemis? I don't know really how to respond to your question. I think we can just leave it as a rhetorical question. So thank you for the question. And that's something for people to ponder. And do we have to worry about these fireballs hitting satellites or airplanes? Or, in this case, the Artemis II mission? Technically, it's possible, but the chance of that happening is so infinitesimally small, I think it's basically non-existent. But technically, it's possible. And if you do have more of these meteors coming in, it does raise up the chance. But space is quite vast, right? We, travel around the world a little bit, you realize that the world's a big place, and well, the space environment is much bigger. And it's not just a plane, a surface, it's 3D, right? So it really spreads everything out. So I don't think it's really something you have to worry about. Because your question is, do you have to worry about it? No, I wouldn't worry about it. And do you think this rush to the moon and pivot in NASA's plans are related to disclosure? Timeliness and missing persons and radio comms on 77? Weird. There's some stuff happening behind the scenes for sure. I think there could also be some distractions that are being engineered right now. So that's also a possibility. I think it's Project Bluebeam, that's what it's called. So I'm just on the camp of just pay attention, be aware, observe, and see what's happening. Why won't they take the sun radiation into account? Are they more concerned with clouds? They are more concerned with clouds. Why are they so careless? Hope you enjoyed your vacation. Yeah, I don't know. I mean, I think they do take this into account, but maybe they don't give it the respect that it deserves. That's my personal thought. I just don't think they treat, I think most people don't treat the sun with enough respect. That was actually a dream I had recently, is that basically it was like one of these realistic dreams. I'll keep it pretty short and sweet. It's one of these realistic dreams. So I was sleeping and I was up on the 11th floor, the 9th floor of a building in Rome, because I was traveling, is like my Airbnb. And all of a sudden the building started shaking like this. And I was like, holy crap, the big earthquake came. Like the big earthquake came. And I'm like praying to God, just don't let this building collapse. Like let everything be fine. And then for some reason the dream shifted to the sun. And the sun was covered in sunspots. Very similar to what we're seeing now. And normally when I have the sun in my dreams, I've had a lot of dreams with the sun and solar flares and stuff. It's interesting. I cover this stuff all the time. But normally I never get like a malevolent energy or feeling from it. This time wasn't malevolent, like bad, but I felt the sun was kind of pissed and was like, you need to respect me. And by you, it really felt like it was a collective call to action, because it was like zooming in and getting closer. And basically there was this knowing that at any moment the sun could do like a massive solar flare or something. And so then I was pleading with the sun, like, dude, just give us a chance. Like, please save us. Like, don't do the thing. We love you, sun. And then the dream ended. I felt like I was a representative for humanity at that moment in time. So yeah, I think that we need to be more respectful of the sun. And just in general, people just don't, I think most people just don't spend enough time thinking about it. So they don't kind of get that information conveyed to them through that meditative state over time. That's really the key. And the ancient peoples, I think they knew this, right? Because they were sun worshippers. So they knew. They spent lots of time contemplating, meditating on the sun, connecting to the sun. And if the sun is the mega consciousness of our solar system, it's going to then provide that information and energy and consciousness and knowledge to anyone that spends time thinking about it. So, how could they have made it to the sun, or how could they have made it to the moon just fine before, but now seeming like all this tech to protect the astronauts is brand new? Love your channel, namaste. That's another question. Apollo missions occurred basically during solar maximum of solar cycle 20, which was pretty active, similar to this solar cycle actually. But yeah, a lot of people have questions about going through the radiation belts. We didn't even really know the radiation belts back then. Now we know a lot more about our space environment. Back then we didn't. So it is a bit odd. I don't have an answer for that. But, it appears that these radiation doses that you get aren't enough to kill you, but it may be a lot. And maybe there's like a cancer risk afterwards. These are things that you have to consider. It'd be quite a lot for you to have so much radiation that you just kneel over and die. But if it's causing DNA breaks, single and double, 10 years later, maybe you get some sort of growth on your arm or something like that. So I think that's what we probably more likely. Now, if you're doing multiple trips to the moon and back, moon and back, moon and back, you don't have good shielding, then yeah, maybe your radiation tally really starts to add up and become problematic. To what direction solar flares possibly fire if this new comet hits the sun? Where is Earth at the time? Well, if it does hit the sun, it'll kind of be on the other side, thankfully. But we don't know how it's going to interact. Maybe just getting close enough will cause some of these sunspots to just get more active. This is a possibility. And do you think the sun will also affect Yellowstone? Probably not. I think Yellowstone's been chilling now for 700,000 years or so, so I think it's going to continue chilling. So yeah, that's if you ask, do I think? That's my thoughts on that. Thank you, Sally, for the super thanks, and also to Tara, thank you so much for the super thanks as well. And with that, I'm going to sign off on this live stream. So thank you everyone for joining. I wish everyone the best. I also wish the astronauts and all the space crew the best with the Artemis II mission. I just think that there are more risks here than maybe are being advertised, right? That's kind of the key. And hopefully the risk is still overall quite low. I'm not enough of an expert to give like clear percentages on the risk here, but I do think it's higher than advertised. It's good to be aware of these risks, especially if you have an interest in the space environment, and hopefully nothing happens. Simply put, hopefully nothing happens, but we do have some pretty big planetary alignments coming up. I can actually show you that really quick. Okay, one second. Our mod here is saying, check to see if it was canceled. I think you mean Artemis II. So let's see what you're talking about. We'd have to go to our latest news for today. No, looks like it's fine. I haven't seen anything about it being canceled. But thank you for that. If we look at our solar system geometry really quick and get that going right here, we see that we have a pretty big planetary alignment right during this time frame. So let's go forward to the first with our full moon right here. And we have a loose alignment between the moon, the sun, Mercury, Mars, Saturn, Neptune. So that's all forming this alignment like this. And then we also have a near quadrature alignment here with Mercury, Sun, Venus, Uranus. Not exactly, but pretty close. And then on the 4th of April is when we have the sungrazer comet fly in. So we do have some significant planetary geometry right now as a result of that. And this is going to continue because of this conjunction with Saturn, Neptune. That's the thing. The longer we have that, the more likely we're going to be privy to this sort of enhancement in space weather. And until they kind of break apart and lock out of their conjunction, you know, decouple from their conjunction, the risk of these alignments triggering things like solar activity, earthquakes is higher. So yeah, thank you all so much, everyone. Wishing you all well. Please take care of yourselves, and I'll be back for sure with a live stream of the launch on the 1st, or if should they go through with it, that is going to be I think the earliest that they can launch is, I have it written down here, 6:24 p.m. EDT, so Eastern Daylight Savings Time. The full moon is April 1st at 10:52 p.m. EDT on the 1st. So I'll be back with an update for you guys then, should it go ahead, and of course the more updates on our Earth, our sun, our cosmic environment, and more. Much love to you. See you all soon.